Lashley Advanced Bi-Rail Systems presents the LABIS train, an American high-speed rail concept. It will be built with existing technology. It will be safer and more effective than existing systems. It will board and debark passengers without stopping. It will have much lower environmental impact than existing systems. It is an American concept. LABIS train embodies a wide, lightweight vehicle with a low center of gravity running between elevated rails at speeds in the order of 200 or more miles per hour. Loading, unloading passengers is by way of a shuttle vehicle, which transports passengers from a boarding area to and from the train, docking with it as it continues to move. At LABIS, we feel that the most fundamental problem with contemporary rail vehicles are low lateral stability, the very unfavorable vehicle-to-payload weight ratio, and the antiquated passenger handling technique. The low overall speeds, high fares, and general inconvenience to the traveler precipitated by these problems result in low ridership and low revenues. The lateral instability is caused primarily by the design of the vehicle, which results in a very high vertical center of gravity over a relatively narrow set of wheels. The width and height of the vehicle combine with its great weight to aggravate the instability. Existing and experimental high-speed rail systems address the lateral instability problem by very expensive attempts to stabilize their roadbeds. But it must be recognized that the 56.5-inch gauge track, at best, will continue to impose limits to the possible lateral stability and vehicle width, regardless of how stable the roadbed may be. The LABIS train will be about 15.5 feet wide and 8.5 feet high, with the bottom some 6 inches higher than the rails. The wheels will be set on the sides rather than under the vehicle and will run on 14.5-foot gauge rails. Aerodynamic lift will be controlled by spoilers on the top. This low-wide configuration, besides making possible a much more usable, roomy interior, will result in a greatly lowered center of gravity and provide the required lateral stability. This highly stable vehicle will be able to travel safely at the higher speeds required in today's world. The very high vehicle-to-payload weight ratio of contemporary trains and resulting high operating costs force fares up. 1,000 tons of Amtrak train carrying 10 to 20 tons of passengers must necessarily force fares out of reach of many citizens if the train is to pay its own way. We believe that the need to provide quality service at attractively low fares cannot be overemphasized if any system is to attract and hold the required ridership. The LABIS train will be built using the light, strong monocoque construction techniques employed by today's aircraft industry. The much lighter weight of the LABIS train will provide a much more favorable vehicle-to-payload weight ratio, thus enabling much lower operating costs and fares. Another major factor impacting the overall speed of most passenger-carrying systems today is the necessity to provide service to many locations and the inefficient passenger boarding methods. The more passenger pickup drop stops required, the slower the overall speed. It's interesting to note that because of its highly inefficient landing, takeoff, and passenger boarding characteristics, even the airplane, with all its speed, would not provide much faster coast-to-coast service than the contemporary train if it were required to make the same number of stops. Passengers will board and debark the LABIS train using a shuttle car. The shuttle will move through City A, picking up passengers at conveniently located points in the city, and wait on a side track for the main train. When the train passes, the shuttle will switch onto the main line, overtake, and dock with it. The shuttle then discharges the passengers from City A into the train, takes on passengers for City B, uncouples and proceeds into City B, where it drops its passengers at their preferred stations. Thus, the train is not required to stop to pick up and drop off passengers as is necessary with other systems. The railway required to support the LABIS train will consist of a pair of rails supported high enough off ground level to ensure clearance of ground traffic or other surface hazards and provide isolation from most weather conditions. Since the vehicles will be much lighter than contemporary trains, the very dense pattern trestling presently used will not be necessary. One need only to consider the size of the wheel struts of the modern-day 727 airplane to get some idea of the size and structural density of the support required. Concrete piers will be poured on stable ground strata and to a predetermined height. Prefabricated sections of the rail support system will be set on the piers and fastened together, forming the rail support structure. Since the structure is supported on the piers, the intense filling, compacting, and grading needed for present-day and levitated systems will be greatly reduced. Power for the LABIS train may be generated in appropriately located coal-fired electricity generating plants and from existing commercial power companies. The plants, equipped with the necessary pollution control devices, will provide power from a low cost, plentiful fuel with minimum environmental pollution. The train will be headed by an aerodynamically designed primary control coach, which will be equipped with the necessary control, communications, and warning systems. Part of the warning system is an electronic device which monitors the track condition and warns of rail faults, displacements, track obstructions, and other hazards in time for the train to be stopped. Behind the primary coach will be appropriate numbers of cars to accommodate expected passenger loads. The train may include both powered and passive coaches. The many driven wheels of the powered units provide the necessary tractive friction for grade climbing. Powered units will operate under control from the primary coach while coupled in a train, but may be capable of operating individually. This will facilitate adding or dropping cars in transit, adjusting the train size without stopping it. Utilizing the shuttle loading-unloading system, a train running at 200 miles per hour could cross the United States in less than 15 hours, picking up and dropping passengers at some 40 points. It is worth noting that the LABIS concept is an American concept. It will not require mass exportation of American jobs or vast importation of foreign technology to accomplish. The LABIS concept is based on a new configuration and application of proven, known technology, of long-accepted precepts of physics, geometry, and mechanics. Development work will, of course, be necessary, but we suggest that such development effort on the LABIS train is apt to be less than that required to produce a useful, reliable, economically acceptable 200-mile-per-hour system from any existing or experimental system.